All right, welcome back to 9.5. We're going to find sums of finite geometric series that are given to us instead of being listed out. They're given to us in sigma notation. So remember that sigma notation, sigma means sum, where m, the letter here, goes from 1 to 8 in this instance. So sum of m starting at 1 going to 8. And so you might remember this as being the finite, the formula for a finite geometric sequence. We learned this when we were talking about geometric sequences. So this is the formula for a geometric sequence. And so when we plug in 1 to m, we would get our first term, and then all the way up to 8. And we could list out our sequence. But we don't actually have to do that because we just want to find the sum. So we're going to use our formula for our sum, going from 1 to 8. So going from 1 to 8, that's 8 terms. So n is going to be 8. So remember, our number of terms is final minus initial plus 1. So if it starts at 1, it's just the final, but otherwise you're going to have to use that formula, final minus initial plus 1. So 8 minus 1 plus 1. And this would be a finite series, this would be a geometric sequence with the first term of 1. Because remember that the formula was first term times r to the n minus 1. So the first term would go here. There's nothing here, so our first term is 1, which you could figure out by plugging 1 in here. 1 minus 1 is 0. Negative 2 to the 0 is 1. So our first term is going to be 1. And that we need that for our formula. So I'm going to write that down. So again, that's negative 2 to the 1 minus 1, which is negative 2 to the 0, which is just 1. So our first term is 1, and n again is 8. We found that by doing 8 minus 1 plus 1, which is just 8, right? So 8 minus 1, and then you always just add 1 after you do that. Again, if you start at 1, you don't have to go through all this mess. If you start at 1, then your n is just the number up here. Okay, so now that we've done that, we can use our formula. Oh, r. R is always going to be the number that has the power. Okay? So r in this case is going to be negative 2. So now we can use our formula. So we have S8 equals 1, because that was our A1, times 1 minus negative 2 to the 8th power over 1 minus negative 2. R is not always negative. It just has been in all of the examples we've done so far. Okay, so we're going to do negative 2 to the 8th power, which is going to be positive. So negative 2 to the 8th power is 256. So again, this 1 is not going to change anything, so I'm not going to write it in the next step. So I have 1 minus 256 over 2 minus negative 2 is 3. So on top, 1 minus 256 is 255. Negative 255. So we have negative 255 on top. Divide that by 3. We get negative 85. So I'm going to write up here We have negative 255 divided by 3, which is negative 85. So that's our answer to the first one. Okay, so if you need to pause and finish writing things down, now would be the time to do it. I'm going to erase so that we can do the next one. So here we go. Okay, so on the second one, we have n from 1 to 10. So n as in our number of terms, not this n necessarily, but n as in our number of terms is going to be 10. R, again, is going to be this number here. So R is going to be negative 4. And A1, again, we're just going to plug in 1. So we get negative 4 to the 1 minus 1, which is negative 4 to the 0, which is, again, just 1. So A1 is going to be 1 again. Again, if you have a formula in this form, should be the number out here. So we should have we could have predicted that A would be 1, but I wanted to show you the formal way. So yeah, so we have all of our pieces, and now we can use our formula. So we have S, 10. So we have 1, that's our first term, times 1 minus negative 4 to the 10th power over 1 minus negative 4. Negative 4 to the 10th power is going to be positive because it's an even power, and that's a really big number. Yeah. So I have 1 minus this number. Nope. That number, divided by 5. So I'm going to do 1 minus that number. So in my calculator, I'm just going to hit 1 minus answer. So I don't have to type in anything. And then I'm just going to divide what I get by 5. And so this equals negative 209,715. So 209,715 is big number. But yeah, so well, actually, it's a really small number because it's negative. But anyway, that is how we find the sums of finite geometric series using sigma notation. And I will see you in the next video.